this video, I'm going to take a look at synthetic division. Synthetic. When I do this lecture in class, I always first ask, what is synthetic? And usually the responses I get back from students are anything along the lines of artificial or fake. And those are great ideas to kind of hold in the back of our mind. And then I always ask the follow-up question, well, where have we heard this term synthetic before? And more often than not, the response I get is synthetic oil. And I think, again, that is a great comparison to be making. Our synthetic oil is in a lot of ways more efficient. It's better than the real stuff. Now, is it actual real oil? No, it's not that same compound that we had 20 years ago. But a lot of new cars run more efficiently off of it. For instance, you might have oil changes every 5 or 10,000 miles, not every 3,000 miles. It may make the engine last longer. So in a lot of ways, it's better. Now, can I take that synthetic oil and put it into an older car? No, I cannot. Your car engine's going to explode. So we can't always use the fake stuff. We can't always use that synthetic oil. But in a lot of ways, it does better than the original. And synthetic division is the same. Synthetic division is going to be faster. It's going to make our lives easier. It's going to be more efficient. But it cannot always be used. In some problems, we just can't use it. So what I want to start off by doing is looking at this problem that I had actually started with in the last case, in the last example. Don't know why it got so big. So this last problem that we did in the last video, I should say, the last video, the first problem that I did was this one right here. So we would divide x squared minus x minus 6 by x minus 3, got x plus 2, and we did that by using long division. What we noticed in this long division is we were doing the same process over and over and over again. So we were starting with the question, all right, what do I need to multiply x by to get to x squared? Well, that needs to be an x. And then I did that multiplication. And then I subtracted. Then I started the whole process over again. What do I need to multiply x by to get to an x? 8x. That's a 2x. Sorry, I can't remember. My writing when I crossed through is a 2. We multiplied. We got to an answer. We subtracted. So every single time we did long division, figure out what we multiply by, multiply, subtract. Figure out what we multiply, multiply, subtract. We're doing the same thing over and over again. So if we could figure out a way to kind of leave off some variables, that might make our lives a little bit easier. Or not leave off as much as let the position dictate the variable. So I want to start by doing the same problem using synthetic division. I'm going to have a little division house still, but what's going to go inside that house and outside is a little bit different. Before, the outside was what we were dividing by, and the inside what we were dividing into. Let's switch that position, and not switch the sides, but now the inside is going to be still this left-hand side, what we're dividing by. The right-hand side, what's outside the division house, is what we're dividing into. The other thing I'm going to do is I'm not going to write down the variable every single time, because the variables, notice we were saying keep that position lined up. We kind of knew what to expect just by the position that something was in. So if I knew that these were my x's, I knew everything in this column was x's. So we're going to use a position to dictate what the variable is. I'm not going to write those variables every single time. So let me start by writing the right-hand side, what we're dividing into. What I'm dividing into is an x squared minus x minus 6. I'm only going to write down the coefficients. So there's a 1 on the x squared, there's a negative 1 on the x, and there's a negative 6 as a constant. Inside the house, what I'm dividing by is the x minus 3. I'm going to do two things a little differently here. I'm not going to write down the x. I'm only going to write down the constant. I'm actually going to switch its sign. I'm going to switch that to a 3. And I'll describe that a little bit more in a few minutes, but we only are going to write down the opposite sign is what we have here. Let me do the division, and then we'll talk about what's going on. So, in our long division, we figured out what we multiplied by. Notice that is just always the coefficient of the first term. Then we had the 1 there. It's just the coefficient. Then we multiplied. Then we subtracted. The first term always comes straight down. The 1 comes straight down. Then I actually multiplied. I said, let's take that 1, let's multiply it to both terms. So I'm going to multiply the 1 by this number in the box. That's going to give me 3. So we multiply to get back up. Then we subtracted. Now the little difference here is to get down, I'm going to add to get down. Negative 1 plus 3 is 2. Add down. Then I'm going to multiply to get back up. 2 times 3 is 6. I add my way down, I get a 0, and so I'm left with 1, 2, and 0. Now, we started with a polynomial. We need to get back to a polynomial. We've got to put the variables back on this thing. And so the way that works, this polynomial is always going to be 1 degree less than what we started with. We started with an x squared, remember? And so this has got to be an x plus 2, the same answer we got before. Another way to remind it, that last position, remember it, that last position is always your remainder. So this is saying a remainder of 0, and then from there just kind of step it back up. There's our constant, there's our x, nothing else in front of it. So we get to an x plus 2. A couple things a little different than before. Rather than subtracting, we were adding. Why did we do that? Well, we switched this sign right here. We switched that sign, and there's 2 reasons that we do that. You don't have to. I should point that out. Some books, some teachers won't tell you to switch the sign. They'll leave it the same, in which case you would subtract. However, one of the most common mistakes, computational mistakes, is in subtracting. Even though it's a very basic operation, we just easily get confused. We forget to subtract every single term, or we forget double negatives turn into positives. And so why not fix that most common mistake at the very start? By switching that one sign, we don't have to subtract anymore. We get to just add. So that is one computational reason to do it. The other reason to do it goes into what we're getting into, factors and roots of polynomials. We talked before about how this polynomial could be factored. It was factored as an x plus 2 and an x minus 3, and we're dividing by the x minus 3. X minus 3 was a factor of the polynomial. It went in evenly. It had a remainder of 0. If x minus 3 is the factor, if we were to set that equal to 0, x minus 3 equals 0, and solve, x is equal to 3 would be the root, or the 0 of the polynomial. Now, we haven't gotten too deep into how to find zeros and roots for more complex elements, but if we have something basic like this, where something factors nicely, we can easily find its root by setting the thing equal to 0, by setting the factors equal to 0. So inside of this box, always put it in quotes, is the root of the divisor. Now, why do I put in these little quotes? Because if it doesn't divide into it evenly, well, then it's not really a root. It's almost like we're trying to check if something is a root. Long term, that's exactly where we're headed with this. By dividing these polynomials, we can check to see if something is a root. So we are taking that denominator and we're switching the sign to get what we are dividing by. We're going to do some more examples with these. I also said that with synthetic division, we can only do this for polynomials in certain cases. We can only do it for certain polynomials. We can only use synthetic division when we're dividing by a divisor that is linear with a coefficient of 1. Synthetic division only works for linear divisors with coefficients of 1. So for instance, a couple things that we could not do. 5x cubed minus 2x squared plus 3x over 2x plus 1. The problem there being 2. That is not a coefficient of 1, and so we cannot do that division with synthetic. We would need to go back to long division. We have 2x to the 4th minus 3x squared plus 2x minus 1 over x squared plus 3. Cannot do that using synthetic division. X squared, that's quadratic, we need not linear. We need to go back and use our long division. So we can only use synthetic division for linear divisors with coefficients of 1. Let's take another example. Let's take x to the 4th minus 5x squared plus 2x minus 1 divided by x plus 2. First thing I'm going to do is set it up in my little box. I'm going to put the negative 2. The opposite sign is what we started with, or what would be the 0 of this thing, of the denominator. Then on the right-hand side of that division box, I'm going to put my coefficients. My first coefficient is 1. Notice I have no x cubes, so I've got to put a 0 in there. When I was doing the long division, I said that the zeros are not mandatory, but they're absolutely mandatory with synthetic division, because synthetic division, we use the position to drive what the variable is. And so by leaving out that zero, we've mixed up, we've ruined the positional element of the variables. Then we have a negative 5x, we have a 2, and we have a negative 1. I think it is always a good idea to do a double check, and you can do that double check by just kind of counting your way back up. Constant, 2x, x squared, x cubed, and x to the fourth. Notice if we had that 0 not in there, we'd have our x squared, but then we'd be saying we have a 1x cubed, and that's not true. So always, before you actually start your synthetic division, just count your way up, like I just did, to make sure we have all the variables. This one I'm not going to show the little lines going up and down, I'm just going to do it. So the 1 comes straight down. We multiply to get on top of our horizontal line here. 1 times a negative 2 is negative 2. Add our way back down. Multiply back up. Negative 2 times negative 2 is 4. Add our way down, we get a negative 1. Multiply back up, we get a 2. Add our way down, we get a 4. Multiply back up, we get a negative 8. Add our way down, negative 9. That would be our remainder. And so now we got to just put the variables back on it. We started with an x to the fourth. We divided by a linear, so we're down to an x cubed. 1x cubed minus 2x squared minus x plus 4. And that 9 in the last position is our remainder, goes over the x plus 2. And so that is our answer when we divide these two polynomials. Let's do one last one. Let's take a 3x to the fifth minus 2x cubed plus 5x divided by x plus 1. So I'm going to set it up first in my little division house. I'm going to put the negative 1. My coefficients are 3, 0x to the fourth, negative 2x cubed, 0x squared, 5x, 0 is my constant. Don't forget that constant. That is always one of the most common zeros I see forgotten. You've got to have every single term. That includes your constant. That'll make a huge difference, because otherwise when you get to that last line, you're shifting your remainder over by 1. So doing a double check, 0 is our constant, 5x, 0x squared, negative 2x cubed, 0x to the fourth, 3x to the fifth. Perfect. 3 comes straight down, multiply up, add our way down, multiply our way up, add our way down, multiply up, add our way down, multiply our way up, add our way down, multiply our way up, and add our way down. See how quickly that all took place? That is the benefit to synthetic division. It becomes that quick. And now we just got to put the variables back on it. 3x to the fourth minus 3x cubed plus x squared minus x plus 6 minus 6 over x plus 1. And there is our answer. Synthetic division and long division are both incredibly important. Synthetic division is just so much faster. So yes, you can get through life without synthetic division. If you never learned it, you would just be doing things harder and slower. Long division is incredibly important because synthetic division does not solve everything. It can't deal with all divisions. So we have to know long division. Synthetic division, it just makes your life so much easier if you know it, and I would argue it's a fairly simple process too.